Alright guys, so today we're going to look at equations that have no solution and infinitely many. Some equations do not have one solution. So just to refresh our memory, one solution is an equation. Whenever we solve that equation, we get x equal to any number. So after we isolate the variable, meaning we get the variable all on one side, we're literally left with x or any letter equal to a number. So an example of that might be x equals 5, x equals 10, and such forth. This means that there is only one x value that we can plug into the original equation in order to make the left-hand side of the equation and the right-hand side of the equation equal each other. So that's the kind of equations that we've been doing. Today, I'm going to introduce an equation, once we solve it, how it could have a no solution as its answer or infinitely many. So when solving an equation that has no solution, you will obtain an equivalent equation that is false for any value of the variable, such as 0 equals 2. Well, we know the number 0 will never equal the value of 2. If you have $0 and I have $2, we do not have the same amount of money. So that statement is not true. We would say that it's a false statement. On the flip side, when solving an equation that has infinitely many solutions, when you obtain an equivalent equation that is true for any value of the variable, such as 2 equals 2, that is a true statement. So what this means is there is more than one answer you can put into the equation that would get our left-hand side equal to the right-hand side. And to kind of go back here with no solution, there is absolutely no number you can put in to our equation to get the left-hand side equal to the right-hand side. So that's kind of like the definition behind both of these. So let's go ahead and solve. This one already says we're going to get an answer of no solution. So let's go ahead and see what that looks like. So I'm going to first draw my line down the middle. We know the very first thing that we do is distribute. However, don't see anything that I need to distribute. Combine like terms. Once again, I can't combine either one of these because they both have to have an x. So I'm going to move on to my third step, which is getting my x's all on the same side. I know that if it's a negative 4x, in order to bring it across the equal sign, I have to do the opposite. So I'm going to add. I know that cancels out. I'm going to do this over here. And wait a minute. Negative 4 plus 4. That gives me 0. Okay, bring down my 3. Bring down my equal sign. Bring down my minus 7. Well, I know anything times 0 ends up canceling out. So they cancel out on both sides. I now have no x's. So I'm going to bring down my 3, bring down my equals, bring down my 7. Well, this means that, well, you first off know that 3 can never equal a negative 7. So with that being said, I know that this kind of an answer is a no solution type of equation because these two never equal each other. They never could. Oops, that's not a check. That's an X. When you ever end up with your last step looking like this, I know this is a no solution answer because the left-hand side does not equal the right-hand side. That's not a true statement. This is a false statement. So if I can't plug in any number for x in order to get this side equal to this side. So that's what a no solution problem looks like. So now let's move over to what an infinitely many solution looks like. So I'm going to draw my line down the middle first. And I always know I got to distribute first. So I'm going to do that first. I'm going to bring down my 6x plus 4 and then distribute. Well, I'm going to use my calculator for this. So I'm going to do 4 times 3 divided by 2. And that gives me 6. Bring down my x. 4 times 1 is 4. Awesome. All right, now once again, I'm gonna bring my x's all on the same side. So I'm going to bring over this one. I'm gonna subtract 6x, awesome. Subtract 6x. Oh, wait a minute, 6 minus 6 is 0. Once again, I know anything times 0, whether it's a letter or a number, cancels out. So that technically cancels out too. So I'm left with 4 equals 4. I know 4 does in fact equal 4. That is a true statement. So I know that this answer is infinitely many solutions. So what that means is I can plug in more than one number into the left-hand side of the equation and the right-hand side of the equation to get these equivalent. So, I also tell students that I would accept no solution or, NS. And then I would accept, if you wrote infinitely many solutions, I would also accept IMS as your final answer. Just using that first letter to represent each of those words. So I would accept either answer as your box answer for either of these two problems. All right, I want you guys to go ahead and just pause the video for me. I want you to try these 4 on your own. Once you're ready to move on, please go ahead and hit pause and just check your work. All right, at this time, you guys should have tried all 4 problems, and I'm gonna go ahead and move on. So I'm subtracting 2x, they cancel out on both sides. I'm left with 1 equals -1. Well, I'm gonna make that a little bit smaller so I have room to write. That is a false statement, so that is not true. So this is a no solution or NS. I don't care, you can use either one. And you don't have to show like I did up here how it's 0x. You can just do the crossing out like I did there to show that it represents 0. All right, next one, I know I need to distribute. Some of you guys might recognize at this step, if the left and the right-hand side are identical, meaning that this term is positive over here, it's positive over here, this term is negative over here, negative over here, you might already be able to tell it's infinitely many just from this step, but I'm just going to keep going. I'm going to get rid of the t over here. They end up canceling out because that's 0. 3 minus 3 is 0. Bring down my -2. Just recognize that these numbers are negative, just like how this one over here was negative. And then -2 does in fact equal -2. That's a true statement. So I can write infinitely many solutions or IMS. I don't care. Oops. Oh boy, we'll see how this does this. Okay, it didn't. Which of those 2 responses you give me. All right, number 6. I'm going to distribute on both sides. Ooh, this is a lovely fraction. So I would have 2/3 b plus 3 equals 2/3 b plus 3. I'm gonna bring my b's all over on the same side, and they obviously cancel out. Oops. And that's a true statement, so therefore that is infinitely many. Or IMS. Don't care how you write your answer. Biggest thing is you're recognizing, and I'm not going over that we multiply when we distribute. For actually none of these, we had to combine like terms before we solved for, or brought all the letters over to the same side. But if you need more of that step-by-step process, please let me know. Maybe you can come in during flex time next week. I'm gonna do this next one, double distribute. I'm gonna go ahead and bring over this 12v, that gets 0. This also is 0. I have 30 equals 1. That is a false statement. So that is not true. You don't have to write that X, but that is no solution. Ew. Or NS. And then if your last step, once again, if we had a letter equal to a number, that's considered a 1 solution. So that this is a 1 solution and so is this. 1 solutions are the kind of problems we have been doing. Now we're just introducing, well, what if I have a number left on both sides? What kind of a response would I give if they're not equivalent? What kind of a response would I give if they are equivalent? So the IXL and the check-in go over problems like these on top of ones that we've covered recently. So go ahead, start with the IXL XDE, and then do that check-in. Just know that the check-in, you only get 1 attempt.